Okay, boys and girls, the last part. We're almost there. Confused? You won't be after the next episode of The Filing Machine. In today's episode, I'm going to put a pin in that hole. That pin will fit in a slider I'm going to make out of this hex, but it's going to be rectangular because it has to fit in this slot perfectly, of course. A nice sliding fit. And then I'm going to power the filing machine with my old Shopsmith. That thing, my father bought it when I was born, 56, and I still have it and I'm still proud of that thing. I will use that to power the filing machine for now, and we'll see if it works or not works, but it's an experiment. Let's get cracking. This shaft needs to fit in here, means it needs a 6mm short piece with a tight sliding fit in there, so I can pop it in, and then I'll pin it down on the other side to lock it in. But it needs to be a fairly tight fit so that it's perpendicular to the surface. So I'll have to go slow and get it right. My glasses. All I need to do is file the edges and make a little chamfer. I always like filing with my left hand at the base because then you can control it better, because if you're standing like this, you're standing over the chuck and it just doesn't work with all your hands. I know everybody does that, but... and of course I dropped it. Okay. It's clear that my controller board needs replacing. It's always scary milling that close to the chuck jaw. Ugh. Okay. This one is too low, yeah. I don't know why, but I always take it away. The parallel. I think that's one of those habits that you know you shouldn't have, but you just can't break. Oh, I have way more than enough thickness, but the width is almost there already. Jeez. Looking at the sizes, and this thing is too thick, the block is too thick by 2 millimeters. Well, it slides. And with a little lubrication it will slide for a while. But of course this exposes the fundamental mistake I made with this sanding machine. Bronze sliding in aluminium, that's gonna go. I should have made this out of stainless, out of cast iron. But having said that, sometimes it's so nice, isn't it? Going to use a colored system to hold the files. I found a nice colored system on Thingiverse. I'll put the link in the description. Tricky thing with STL files quite often is to find the center of the circle. So here I'm just zooming in and centering it, making it roughly the same diameter as the hole, and just centering it visually. And usually that's more than enough. Now that it's centered, I can make the collar the right length. And of course then I'll need to add a hole for the vertical shaft. And let that go all the way through the collar. Then I'll put 3 cross holes in there just to use set screws to tighten it to the shaft. And select that, rotate 123 times, and we're done. Nice and simple. Okay, so the only thing we need to do now is export this collet holder and print the damn thing. Using red again because I like that color red. I have different pins for the different inserts because they're different diameters, of course, inside. Power on. What's the temperature set to? 250. It's PLA, so that's fine. Another one. Yeah. Okay. Wait till the thing is up to temperature. Yeah, okay. Connect and let it heat up. Where's my glasses? There. You can really feel when the temperature gets, when the insert reaches the right temperature, because then the force needed to push it down reduces dramatically. I wonder if Stefan of CNC Kitchen ever did test to see what the difference is with different temperatures, if they're stronger or not. You can see that it's deforming and it's taking along, so I'm pushing a bit too hard. Luckily for this end I have 4 inserts, so I can do better with an X3. Push the last bit in with cold metal. Yeah, clearly a little bit too so we'll increase the temperature. To 55. Wait a little bit longer. The temperature on the solder iron was set to 220, which is too low. Because I was looking it upside down, I thought it was 250. So I upped the temperature for the last one, of course. I mean, I could have found this out earlier, but no, it's always the last one. This definitely melts in better. Okay, done. Next time, assembly. Nice bag of screws. Oh, those are nimble screws. 4, 7 should do it. This goes on like this. But then I can't get this in. No. Let's do that first. Okay. Fits neatly into these slots. Yeah. Don't know if my drill can handle this. Yes. Hoping to use this Shopsmith to power, but the lowest it will go, the shaft still doesn't work. I designed it for a specific type of file, but these are the files that I'm going to use because I couldn't get them because of COVID. Everything was shut down. So if I clamp that in here, well, you can see the filing starts here. And even if it's this high, you know, it's too high. So I'm printing another table on top, an extension of this table, because I glued it together, so I'm screwed. So I'm printing another extension, put the table on top, mount the file, so at least I can file, and I'll use a drill or something to power it for now. Well, contrary to popular belief, I am stupid. But once I got my gelatin mass, I call a brain, working, I actually figured out that of course the Shopsmith will work. And yes, it does work. I'm trying to do this handheld because otherwise you won't see. The final part. So I printed a little table. The system works. I'm surprised how well everything holds together. And it's going to be interesting to see how long this will last. Once I get the file attached properly, I'm going to use it a lot because I need to make for the props. I need to make a lot of little aluminium pieces that I need to sculpt. So yeah, but it's going to be interesting to see if this thing lasts. And I have an idea for a motor. I'm going to use that speed motor, but maybe with a gearbox or something I'll build. So eventually, one day, I will show you how it turned out. Okay? It's a deal.